Okay, so the first law is the incident ray, the refracted ray, and normal at the point of incidence on the interface all lies in the same plane. Okay, this is interface surface, interface surface. Okay, this is O is the point of incidence, point of incidence. Okay, so when the incident ray falls at the interface surface at point O, then the refracted ray bends towards normal. This is refracted ray. Okay, then all three lies in the same plane. For example, if this is interface medium and this is the incidence ray, then the law of refraction is explained in the way that the incidence ray, normal, and the point of incidence all three lies in the same plane. Then this is the law of refraction. Okay, like if you take three lines, then if the lines are in the plane, then it is the law of refraction, and any line in out from the plane, then it is not considered as the law of refraction. Okay, second law of refraction is the ratio of the sine of angle of incidence. Okay, that is the ratio of sine of angle of incidence to the ratio of to the sine of angle of refraction is always a constant for a given pair of media. Suppose the interference surface is connect the two media 1 and media 2, having the refractive index mu1 and refractive index mu2. Therefore, the ratio of sine of angle I to the sine R is equal to a constant which is given by mu2 by 1, or we say refractive index of second medium with respect to first. Here noted that the second medium is responsible for the bending of light, as I explained in the previous lecture also. Okay, now it is also observed that when the light is traveling from the air medium to the any medium, air to any medium, then the speed of light is reduced by a fraction, like for refractive index of any medium is greater than refractive index of air, which means any medium is optically denser than air. Therefore, the speed of light speed of light is smaller in any medium than air. Okay, and speed of light in air is speed of light in air is equal to speed of light in vacuum is nearly equal to speed of light in vacuum. Okay, that is C is equal to 3 into 10 to the power 8 meter per second. Okay, now we can also define the refractive index in the form of, or in the ratio of the speed of light in air to the speed of light in medium. Okay, just note down it. Okay, absolute refractive index. Okay, this is, it is defined in the ratio of, it is defined as the ratio of speed of light in air to speed of light in air to speed of light in medium. Okay, that is refractive index is equal to speed of light in air C to speed of light in medium is V. So mu is equal to C upon V, where V is speed of light in medium. Okay, now the value of speed of light in medium is C upon mu. Here mu is always greater than 1, which implies here the speed of light is inversely proportional to the refractive index. It is the very most important relation, that the value of speed of light is inversely proportional to the refractive index. Therefore, because the refractive index is always greater than 1, therefore the speed of light is always smaller than c in any medium. Clear? For some medium like refractive index of water is 1.33, glass is 1.5, and tourmaline is 1.37, turpentine oil is 1.37, and etc. Okay. Now next we have the refractive index through two mediums. Or first we learn a bit. Next is reversibility principle. According to this principle, the path of ray of light after refraction or reflection when reversed by a mirror at right angle will retrace its path, which means whenever the light suffer refraction one or more time and then it reflected at right angle, then the light is retrace its initial path. Like the ray is traveling from A to B and then after refraction B to C, when the ray is refracted by the mirror at C at 90 degree, then it is observed that the path of light retrace and the path is reversed with the same path as it comes earlier. Okay. So according to this, when the light is traveling from A, B, C, according to Snell's law, for path A, B, C, sine of angle I, this angle I and this is angle R. Okay, therefore sine of angle I is sine of angle R is refractive index of second medium to first medium. This is your equation first, and another, this is first case, and now second is for path CBA when it is retraced or reversed by a mirror. Therefore sine of angle of incidence, which is in this case is R, and sine of angle of refraction, that is I, is refractive index of the first medium with respect to second. This is your equation second. By multiplying the two, equation 1 multiply by second, we get sin I upon sin R is equal to is multiply with sin R by sin I is equal to refractive index of second medium with respect to first multiply with refractive index of first medium with respect to second, is here sin I cancel by this and R also, then we get mu 1 2 into mu 2 1 is equal to 1. Therefore we calculate from here mu 2 is to 1 is mu 1 is to second. This is reversibility principle. Okay. Now refraction through two or more surfaces. Refraction through three medium. Okay, see, suppose we have an activity that three surfaces are, or three mediums are separated by this. Here this is water, this is glass, and this is air, and above it also air. Therefore, a light which traveling from air incident at point B, traveling from A, after suffering refraction at this point, the light is travels with a refraction to point C, and then after it again suffer refraction in direction of D, and then it again suffer refraction here. Mu A, mu W, and mu glass, and here is again mu air. Here you need to understood one thing, that mu glass is denser than mu water is denser than mu air. Therefore, it is observed that when the light is suffer refraction at D, then it travels from denser medium to the rarer medium, and observe that it is moving in direction of E. Okay. Therefore, it is observed that if this is angle of incidence I1, I, and this is first refraction, let's say angle of refraction R1, therefore at this point this is angle of incidence for the second interface surface is equal to R1, and this is R2 at the second refraction. And this is angle of incidence R2 at refraction at D, and this is emergent ray which is equal to I, because as we find the angle of refraction and incidence for the refraction at C is equal to R1 because of alternate interior angle, and in the second medium, that is glass, angle of refraction and angle of incidence is equal to R2. Therefore, we can also say that the angle of incidence is equal to angle of emergent E, that is I. Now, for this, by Snell's law, at B, sine I upon sine R1 is equal to refractive index of water with respect to A. This is your equation first. Second, at C, sine R1 upon sine R2 is equal to refractive index of glass with respect to water, and at D sine R2 upon sine I is equal to refractive index of air with respect to glass. This is your equation second and this is your equation third. Okay, now by multiplying all three, by multiplying equation first, second and third, we get sin I upon sin R1 into sin R1 upon sin R2 into sin R2 upon sin I is equal to mu water into air, mu glass in with respect to water, and mu air with respect to glass. Okay, now here we observe that I cancel by this, R1 cancel by this, and R2 cancel by this. Therefore we calculate here mu W with respect to air, mu glass with respect to this water, and mu air with respect to glass is equal to 1. From here we calculate the value of refractive index of glass with respect to water is equal to 1 upon refractive index of water with respect to air into refractive index of air with respect to glass. Okay, this term we can also written in the form of refractive index of glass with respect to water is refractive index of glass with respect to air to refractive index of water with respect to air. Clear? By using the reversibility principle. By reversibility principle. That is mu Ag is equal to mu Ga. Okay. Now, as we discussed in the previous class, that M21 is equal to mu 2 upon mu 1. By using this, we can say here refractive index of glass with respect to water is refractive index of glass upon refractive index of air, and refractive index of water upon refractive index of air. Therefore, here we calculate that these cancel, and the final relation which we get for the interface of two different medium with respect to air, we get the final result is refractive index of glass to refractive index of water. This is our final relation. Okay, by using the reversibility principle, this we prove that the relation between the two different medium, the refractive index is equal to the second medium with respect to the first. Okay, this is most important relation which on the basis of which we have the numerical of 1 marks or 2 marks when you done the numerical related to based on the refraction through the spherical surfaces. Then this result is in use. Okay, note down this. Now, next we have lateral displacement or lateral shift. Refraction through glass slab, or this is also called lateral displacement or shift. Okay, this is also activity in 11th class. Let's say we have a glass slab of thickness T, okay, and here AB is first refracting surface, and CD is second refracting surface. Okay, then it is observed that when a light is traveling from one medium, let's say air, with refractive index mu1 and suffering refraction at this point, let's say B, then it travels in the direction of C and then it's emerge out from the glass slab in the direction of D. Okay, this is the incidence ray. Okay, now it is observed that when the glass slab is not present in the path of light, then the AB is traveling in this way, and it is observed that the incidence ray in absence of the glass slab is parallel to the emergent ray. Here this is incident ray, this is emergent ray, and this is incidence ray in absence of glass slab. Incidence ray in absence of slab. Okay, then we observe here the incidence ray, let's say ABE is parallel to emergent ray CD. Okay, that is ACBE is parallel to CD. This is the special property observed in the glass slab, and the distance between, or we say perpendicular distance between the emergent ray and the incidence ray is called, this distance is lateral displacement. displacement, okay, or shift, okay. This characteristic of glass slab is known as lateral displacement or lateral shift, okay. Now we can establish a relation between this displacement due to the glass slab in the respect to the thickness of the glass slab. Now we will understood how to correlate the displacement with the property of the glass slab. Now let's say this is normal and this is the another normal M, okay, N and S and M dash. Therefore this is value of angle I, incidence ray, and this is refracted ray. Therefore we calculate here this angle. See, by figure angle ABN, here CH, CF कर लेते हैं, let we use here CF, okay. Then ABN is equal to N dash BF, angle N dash BF, okay. Therefore the value of angle N dash BF is equal to angle I, clear. Therefore this angle N dash BF is equal to N dash BC, angle N dash BC, and plus angle CBF, okay. Here this value is angle I and this value is angle R, and we need to calculate this value which is CBF. Therefore angle CBF is equal to angle I minus angle R, clear. Therefore this angle is angle I minus angle R. Now we have two triangles. One is triangle BHC, okay, this triangle, and one is BCF, okay. Now see, from figure in triangle BHC, okay, here we have to calculate BH and BC. BC is, this is perpendicular, therefore along with angle is base and this is hypotenuse. Then we calculate from here cos R is equal to BH base upon hypotenuse is BC. Here students, we have to calculate the value of BC, so that we get BC is equal to BH is thickness of the slab, that is T upon cos r. This is equation first. Okay. Now in triangle BCF, BFC, okay, here we need to calculate this perpendicular which is equal to D. D is lateral shift or lateral displacement. Okay, therefore this is angle in, this is perpendicular and this is hypotenuse. Therefore sine of angle I minus angle R is equal to CF upon BC. Okay, so CF is equal to BC sine I minus R. Okay, now putting the value of BC is equal to, this we have calculated in equation first, and value of CF is equal to D. D is lateral displacement. Okay, therefore D is equal to T sin I minus sin R upon cos R. This is the relation between the lateral displacement, thickness of the slab with the, in the term of angle of incidence and angle of refraction. That is lateral displacement small d is equal to T sin I minus R to cos R. Okay, this is the most important rule of the refraction of light. Thank you.